Yes.
Round of applause. I'm a singer, so.
Oh.
Is that your major?
Actually, yeah, and actually, mine is relevant, actually. My name is Christine, I am a vocal performance major, and the reason it's relevant to my topic is because about 80 to 90% of my friends are gay. So, my topic is human sexuality, so, according to the Kinsey Institute, approximately 8% of the US population identifies as openly gay, lesbian, or bisexual, though the actual portion may be closer to 10% because some do not admit to their sexual orientation. Although the statistic tells us that this portion of the population is a minority, there has been a plethora of issues, including marriage equality, hate crime prevention, alternative family styles, and suicide prevention, there are opposing viewpoints to each of those, and it isn't just the LGBT community that's interested in them. A very integral facet of these issues is whether or not homosexuality or any non-heteronormative orientation is a matter of choice or chance. Many people believe that the proof or disproof of a biological attribution would clarify whether or not being a non-heterosexual is in fact natural. This information could sway public opinion and in effect allow for easier approval of legislation that reflects said opinion. The claim that I am advocating is that human sexual orientation is determined biologically. Okay, so my supporting claims surround non-heterosexual orientations because much of what I read states that it is easier to find genetic mutations in minorities than to look for what's normal and then, you know. So my supportive claims are, number one, there is a genetic component in determining sexuality. Number two, the environment of the womb impacts development of sexual orientation. And number three, homosexuals and heterosexuals have physiological differences that suggest a biological cause for sexual orientation. Before I begin with the supporting claims, I should give you a couple definitions because there are a couple things that may not be clear for people. What I mean by sexual orientation is a person's sexual attraction. It's not their gender, it's not their gender role or physiological gender. It is just who they're attracted to, which they may state or they may not. The genome, which is the complete set of genetic material present in an organism, and what's important a little bit later on is that the genotype is different from the phenotype. Genotype is everything that's in there, the phenotype is just what's expressed, so I'll get to that later. An allele, which is one of two or more alternative forms of a gene that can be found in the same place on a chromosome, so like, you know, brown eyes or blue eyes, but don't have to get into that. And then the epigenetic or epigenetics, it's basically just resulting from external rather than genetic influences. So something that can affect the genes, but not something genetic. So my first supporting claim, there is a genetic component in determining sexuality. A study from 1993, which I realize is a very long time ago, but it is still being cited today, from Dean Hamer, found that genetic markers were found in homosexuals on the X chromosome, which is the one that your mom gives you. So basically they're saying that's the reason that it hasn't been bred out, is because it continues to present, and because if homosexuals were mating, then they would pass on their Y, well, at least men, would pass on their Y chromosome. So since it's on the X chromosome, it continues to present. And then also that the XQ28 was found to be linked to male sexual orientation with a statistical confidence of 99%. So they're fairly certain that it's hereditary. Which leads me to the other part of his study, which was about the pedigree of the different homosexuals that he studied. That most of them had gay uncles or cousins on their maternal side. So it kind of helps prove that it's an X chromosome linkage. Speaking of relatives, there were several twin studies. The ones that I looked at, there was one in 1991 by Bailey and Pillard of 110 gay men, and it's kind of controversial, but the concordance rate for the monozygotic or identical twins was 52%, which everyone says, well, why isn't it 100? They have the same exact genetic material, which I will get to that later, but the fraternal twins were 22%, and then for non-twin, just regular brothers or adopted was 9 and 11% respectively. The 1993 study by Bailey and his colleagues of lesbian and bisexual women actually had this very, very similar results, with the identical twins having 48% of concordance, which means like both of them are gay or both of them are straight. And then the 2000 study by Bailey was kind of upsetting for him because he didn't get the same statistical significance that he did before, but he did prove that it was that it's familial or hereditary, because in essence that study also had, like, the more genetic material you shared, the higher rate of concordance there was, like the more often both were gay or both were straight. So, okay, I think he said my time is up. Can I have one more point? Okay, so my biggest one that I really wanted to say was about the epigenetics, which is basically explaining why these concordance rates don't work. There are other factors outside of genetics that affect each allele and express or have penetrance on the genome. So basically they're saying sometimes they both have the gene to be gay, but only one of them is expressing it, which I think is a really, really good argument for it being biological. So. Go forever.
All right, Christine, you've got a clear proposition, but you're having to do way too much to get to this argument. You've got, a whole bunch of definitions that you give us at the beginning of the speech, and then you give us an explanation of what the secondary issues are going to be. And basically, you've gone 3 minutes into the presentation before you've actually started your argument. So you're going to have to cut to the chase and be a little bit more efficient in getting your arguments out. Obviously, you run out of time, too, and as a consequence, I think that you're missing some of the key arguments that you planned on talking about in the presentation. It was a little strange because you spend so much time on the genetic research that you do talk about, and most of the explanation of the genetic research is an explanation about why the inconsistencies in the information don't mean the opposite, instead of an explanation about why they mean this is genetic in nature. That's a little confusing, that you spend 2/3 to 3/4 of your time explaining to us why it doesn't mean the negative, it really means the positive here, instead of giving us the positive kind of argument. That's confusing. And since that's really the only argument that you get to, except right at the very end, you have a brief explanation of what this other element would be without giving us the proof on that particular element, that makes the argument even, I think, a little bit more problematic. I think you have a good justification why we're talking about this, but it goes on a little bit long. That needed to be edited down. The background information, like I said, is okay, but again, it's 3 minutes in before you get to the actual argument, and then you spend 3 minutes talking about that first point, trying to explain, 25-year-old data, well, not 25-year-old, I guess it's 21, 22, 24-year-old data that we're going through here. And I think that there's got to be some more information on this subject that continues. I guess maybe it's one of those things where maybe the topic is too complicated in the amount of time that you have with the way you're talking about it. There's got to be a way to simplify this and get to the point. Speaking of simplifying and getting to the point, we have one more speaker I'd like to squeeze in tonight. John, could you?
Thank you.